Hey, hi everyone, welcome back to this video series on Windows Server 2016. Managing a virtual server. We have made use of Hyper-V Manager in order to manage our virtual switches and to create a virtual machine. This tool is all powerful when it comes to manipulating your VMs, and I find myself accessing it frequently in my daily lab. Let's take a look at a few of the other things you can do from inside Hyper-V Manager, as well as discuss other methods that can be used in order to work with the new virtual machines that are being created on your Hyper-V server. Hyper-V Manager. As you know, Hyper-V Manager is a primary tool for managing a Hyper-V server. It is a nice console that gives you a quick status on your virtual machines and allows you to manage those VMs in a variety of ways, something we did not cover. Because I only have one Hyper-V server running, is that you can manage multiple Hyper-V servers from a single Hyper-V Manager console, just like any MMC style console in the Microsoft world. If you right-click on the words Hyper-V Manager near the top left of the screen, you will have an option that says Connect to Server. By using this function, you can pull information from other Hyper-V servers into this same pane of glass. Furthermore, this enables you to run the Hyper-V Manager software on a client computer. You can install the Hyper-V role into many Windows 10 machines, which will also install this console, and then use that local copy of the Hyper-V Manager running on your desktop in order to manage your Hyper-V servers without needing to log into those servers directly. Some of the most useful actions inside Hyper-V Manager are listed along the right side of the console, things like Virtual Switch Manager and the ability to create a new VM. Once you have VMs up and running, you will find a lot of useful functions listed inside the context menu that appears when you right-click on a virtual machine, as you can see in the following screenshot. Some of these are self-explanatory and some are worth playing around with. We have already used connect to our VMs console. Settings opens up a ton of possibilities, and we will take a look further inside the settings menu immediately following this text. One of the most common reasons I open up this right-click menu is for power functions of my VMs. You can see you have the ability to turn off or shut down your VM. Turning it off is like pressing the power button on a server. It cuts off power immediately to that server and will cause Windows some grief when doing so. The shutdown function, on the other hand, initiates a clean shutdown, at least when you are using Microsoft operating systems on the VMs. Shutting down a server is no big deal, but the real power here comes from the fact that you can shut down multiple VMs at the same time. For example, if I was running a dozen VMs all for my test lab and I decided that my lab was taking up too many resources and causing problems on my Hyper-V server, I could select all of my VMs, right-click, and then click on shutdown just one time, and I would immediately kick off the shutdown process on all VMs that I had selected. Once a VM is shut down or turned off, then right-click on that VM will give you a start function. And you can also select many different servers and start them all at once by using this right-click menu. Settings menus. Making in-depth modifications to any of your VMs typically means right-clicking on that VM and then navigating to settings for that particular VM. Inside settings, you can adjust any aspect of your virtual machine's hardware, which is the most common reason to visit this screen. Immediately upon opening the settings, you have the option to add hardware to your VM. This is the place you will go in order to add more hard drives or NICs to your virtual server. I don't know if you can tell from the preceding screenshot, but the add button is currently grayed out. This is important to discuss. Many functions inside settings can be manipulated on the fly while the virtual machine is running. Some functions cannot be accomplished unless the VM is turned off. Adding hardware is one of those functions. If you want to add a new hard drive or your NIC to your VM, you will need to shut down that server before you're able to do it. Next, we should talk about the memory screen. This one is fairly simple, right? Just input the amount of RAM that you want this VM to have available. The reason that I want to point it out is that a major improvement has been made in this functionality. You can now adjust the amount of RAM that a VM has while it is running. In the previous versions of Hyper-V, you are required to shut down the VMs in order to change their memory allocation. But even though my Web3 server is currently running and servicing users, I can pop in here and increase the RAM at will. Let's say my 2 gig isn't keeping up with the task load and I want to increase it to 4 gig. I leave the server running, open up Hyper-V Manager settings of the VM and adjust to 4096 MB. The amount of memory immediately adjusts, and then I open up system properties inside the Web3 server. I can see that the operating system has updated to reflect the 4 gig of RAM now installed. The other useful setting screens are the processor and network adapter sections. You have the ability to define the number of virtual processors currently installed to the VM and performance weights associated with these processors. In the network adapter screen, you can change which virtual switch your virtual NICs are plugged into. I find myself accessing this section often as I move servers from one location to another. Checkpoints. The last part of the settings menu that I want to discuss is called checkpoints. These were formerly called snapshots, which I think makes a little more sense to most of us. Checkpoints is a function that you can invoke from Hyper-V Manager by right-clicking on one or more VMs. It essentially creates a snapshot in time for the VM. Another way to look at checkpoints is that they are creating rollback points for your servers. If you create a checkpoint on Tuesday and on Wednesday, somebody makes a config change on that server which causes problems, you can restore the checkpoint from Tuesday and bring the VM back to that day's status. There are a couple of different ways that checkpoints can be run, and the settings menu is where we define those particulars. Hyper-V console, RDP, and PowerShell. While hardware adjustments to VMs need to be made through the Hyper-V Manager, your daily interaction with these VMs running as servers in your environment does not necessarily mean you have to log into your Hyper-V server whatsoever. As you have seen, if you happen to be inside the Hyper-V Manager anyway, then you can quickly and easily use that connect function in order to interact with the console of your servers through the use of the Hyper-V console tool. Accessing your servers this way is beneficial if you need to see something in the BIOS or otherwise outside of the Windows operating system that is running on that VM. But it's not often that you require this level of console access. When you have Windows servers running as VMs, it is much more common to interact with these servers in the exact same ways that you would interact with physical servers on your network. While I have been accessing my Web3 server through the Hyper-V console so far throughout this chapter, now that I have Windows Server 2016 installed onto Web3 and I have enabled the RDP capabilities on it, there is no reason I couldn't just pop open MSTSC and log into Web3 anyway. The same is true for PowerShell. Since this VM is fully online and has the server operating system installed, I can use PowerShell remoting to manipulate my web Web3 server as well, from another server or from my desktop computer. Once you are finished building out that hardware and installing the operating system on a VM, it becomes a rare event that you actually need to use the Hyper-V console in order to interact with that server. Shielded VMs. There is a new capability in Windows Server 2016 that is going to be very important as companies roll forward with the cloud mentality. In order to explain the benefits that shielded VMs bring to the table, we're going to look at an example of what happens when virtual machines are not shielded. Unless you have already taken the time to roll out all shielded VMs in your environment, what I'm about to show you is currently possible on any of your existing virtual machines. You already know that I am running a Hyper-V host server, and on that host I have a virtual machine called Web3. Now let's pretend that I am a cloud hosting provider and that Web3 is a web server that belongs to one of my tenants. I have provided my tenant with a private virtual switch for networking so that they can manage the networking of that server, and I don't have access to that VM at the networking level. Also, it is a fact that this Web3 server is joined to my tenant's domain and network, and I, as the cloud hoster, have absolutely no access to domain credentials or any other means that I can utilize to actually log into that server. Sounds pretty good so far, right? You as a tenant certainly wouldn't want your cloud provider to be able to snoop around inside your virtual machines that are being hosted in that cloud. You also wouldn't want any other tenants who might have VMs running on the same cloud host to be able to see your servers in any way. This same mentality proves itself out in private clouds as well. If you are hosting a private cloud and are allowing various companies or divisions of a company to have segregated VMs running in the same fabric, you would want to ensure those divisions have a real security between the VMs and between the VMs and the hoster. Now let's have a little fun and turn villain. I'm a rogue cloud hoster employee, and I decide that I'm going to do some damage before I walk out the door. It will be quite easy for me to kick off that web server completely since I have access to the host administrative console. However, that would probably throw a flag somewhere, and the tenant would just spin up a new web server and restore from a backup. So even better than breaking the VM, I'm going to leave it running and then change the content of the website itself. Let's give this company client something to talk about to manipulate my tenant's website running on Web3. I don't need any real reasons. I don't really need any real access to the VM itself because I have direct access to the virtual hard drive file. All I need to do is tap into that VHD file, modify the website, and I can make the website display whatever information I want. First, I log into the Hyper-V server and browse to the location of the VHD file which Web3 is using. This is all on the back end, so I don't need any tenant credentials to get there. I simply right-click on that VHD and select Mount. Now that the VHD has been mounted to the host server's operating system directly, I can browse that VM's hard drive as if it were one of my own drives, navigate to the www root folder in order to find the website files and change the default page to display whatever you want. When I'm finished playing around with the website, I can open up disk management, right-click on that mounted disk and select Detach VHD to cover my tracks. How do you feel about hosting virtual machines in the cloud now? This example cuts to the core of why so many companies are scared to take that initial step into cloud hosting. There is simply an unknown level of security for those environments. Thankfully, Microsoft has alleviated this security loophole with a new technology called shielded VMs, encrypted VHDs. The idea behind shielded VMs is quite simple. Microsoft already has a great drive encryption technology. It's called BitLocker. Shielded VMs are Hyper-V virtual machines that have BitLocker drive encryption enabled. When your entire VHD file is protected and encrypted with BitLocker, nobody is going to be able to gain backdoor access to that drive. Attempting to mount the VHD like we just successfully accomplished would result in an error message and nothing more. Even better is that when you set up your infrastructure to support shielded VMs, you also block Hyper-V console access to the VMs which are shielded. While this in itself isn't a big of a deal as the drive encryption, it's still important enough to point out if someone has access to the Hyper-V host server and opens up Hyper-V Manager, they would generally have the ability to use the connect function on the tenant VMs in order to view whatever was currently on the console. More than likely, this would leave them staring at a login screen that they hopefully would not be able to breach. But if that VM's console had somehow been left in a logged in state, they would have immediate access to manipulate the VM, even if the drive was encrypted. So when you create a shielded VM, it not only encrypts the VHD using BitLocker technology, it also blocks access to the VM from the Hyper-V console. Does this hardcore blocking have the potential to cause problems when you are trying to legitimately browse a VM? What if you needed to use the Hyper-V console in order to figure out why a VM won't boot or something like that? Yes, that is a valid point, and one that you should consider. Shielded VMs make security on your VMs much higher, so much so that you could in fact lock yourself out from being able to troubleshoot issues on that server. As is often the case with everything in the IT world, we are trading usability for security. Hyper-V Server 2016, it's very easy to get excited about virtualization. Build some hardware, install Windows Server 2016, implement a Hyper-V role, and bam, you're ready to start rolling out hundreds of VMs in your environment, right? Not necessarily. We haven't talked all about licensing yet, and too often our technological prowess is limited by licensing requirements. The same is true with Hyper-V. Every VM you spin up needs to have its own operating system license. Of course, that requirements makes sense. Why isn't as obvious, however, is the fact that you can only run a certain number of VMs on your Hyper-V server, depending on what SKU you use for the host operating system. So the biggest gotcha that catches people off guard is that using Microsoft Server 2016 Standard Edition as your Hyper-V server will result in your ability to run 2 VMs too. That's it, no more. You'll be able to launch a couple of virtual machines and will then be restricted from running any more. Clearly, the Standard Edition SKU isn't designed to be used as a Hyper-V server. That leaves you with Windows Server 2016 Data Center Edition. Fortunately, Data Center allows you to run unlimited VMs. This is great news, except for one thing: Data Center Edition costs many thousands of dollars. This is a very limiting factor for development of Hyper-V servers. All of this talk about licensing and how messy or expensive it can leads to one point: Hyper-V Server 2016. It isn't that just a Windows Server 2016, but a Hyper-V role installed. No, not at all. Hyper-V Server 2016 is its own animal. Sorry. It has its own installer and a whole different user interface than a traditional server. Installing Hyper-V Server 2016 onto a piece of hardware will result in a server that can host an unlimited number of Hyper-V VMs, but nothing else. You cannot use this as a general purpose server to host other roles or servers or services. This huge benefit of Hyper-V Server 2016, it's free. You are still responsible for licenses on each of the VMs themselves, of course, but to have a free host operating system that can run unlimited number of VMs, now that's something my wallet can agree with. I have burned the ISO installer for Hyper-V Server 2016 onto a DVD and just finished installing it onto my hardware. The installation of the operating system itself was completely familiar. All of the installation screens and options were the same as if I were installing the full version of Windows Server 2016. However, now that the installer has finished and I have booted into the actual operating system on my Hyper-V Server 2016, everything looks entirely different. We are presented with only a command prompt, and inside that prompt, it has also launched a configuration utility. By using the keyboard here, I can do things like set the host name of the server, join it to a domain, and change networking settings. Once you have finished using the CLI interface to set the core requirements on the server, we really don't need access. We really don't need to access the console of the Hyper-V server again, unless you need to backtrack and revisit this configuration screen in order to change something. Instead, after configuring the Hyper-V server, you simply utilize Hyper-V Manager or PowerShell on another server or desktop inside our network to tap remotely into the management of the virtual machines that are running on this Hyper-V server. In the following screenshot, you can see that I have launched Hyper-V Manager on my Windows Server 2016 that happens to have the Hyper-V role installed, but it is not an actual Hyper-V server. So I have used that instance of Hyper-V Manager to connect remotely to my Hyper-V Server 2016 instance. I can now create new VMs on that Hyper-V server and modify them just as if they were running directly on this server. Similar to the way that most tasks performed on a server, core and nano server are handled remotely through the use of remote consoles or PowerShell. We will make all ongoing maintenance and administration of this Hyper-V server happen from the Hyper-V Manager console. Hyper-V server gives you the security benefits of a GUI-less interface combined with the flexibility benefits of hosting an unlimited number of virtual machines and a price point that nobody can argue with. Summary. I don't have official numbers, but I would risk it to say that today there are already more virtual servers running than physical servers, keeping our world online while the battle continues to rage, which hypervisor platform is the best. Typically, the argument is split, either Hyper-V or VMware. You cannot ignore the fact that virtualization is the way of the future. Microsoft puts great amounts of time and resources into making sure that Hyper-V is always staying on top of the game and introducing more and more features with every release so that you can keep your virtualized infrastructure up and running perfectly all the time. It's the capability of cloud virtualization even more powerful than on-premise Hyper-V server? I would say yes, because the infrastructure that is in place at a cloud service provider is going to be the all-powerful OZ compared to what a single company can provide in their own data center. Does this mean you can forget about Hyper-V altogether and just use cloud service providers? Maybe someday, but that day will be a long time coming. The need for on-premise servers and services is still immense, and some industries are simply never going to permit their data and applications to be hosted by a third party. Understanding the capabilities in Hyper-V and being able to build this infrastructure from the ground up will give you a major advantage when looking for accepting a technology job in a Microsoft-centric organization. This brings us to at the end of our story on the new Windows Server 2016. Many of the topics we discussed are comprehensive enough to fill entire books, and I hope that the ideas provided in this volume are enough to prompt you to dig further into those technologies which you plan to work with. Microsoft technology reigns as the king in most data centers across the globe. The new and updated features inside Windows Server 2016 will ensure that this trend continues long into the future. So this concludes my video series on Windows Server 2016. I hope you enjoyed listening. So if you like listening to this video, please like, share, and subscribe. Thank you.